question to you is, as you're running this experiment, let's say you put up a high voltage, how will you be sure that even at that high voltage, all the electrons have gotten sucked in? I want you to pause and think about this for a while. This is, we have,
pause.
question to you is, as you're running this experiment, let's say you put up a high voltage, how will you be sure that even at that high voltage, all the electrons have gotten sucked in? I want you to pause and think about this for a while. This is, we have everything, but think experimentally, how will you confirm that all the electrons have been sucked in? All the emitted electrons are definitely being collected. What can you do? You should pause and think.
pause and think. 等一下所以现在 yes， 我们放一个 positive terminal，alright， so it means 这个 positive，right， 然后 electron 会 suck 回这里，right， 那但是我们将确保所有的 electrons 都被 suck 去 collector 怎样确保呢？现在这个就是好的问题。
增加 voltage。
even 我们增加 voltage， 然后呢？
它发热点跟着上升不是
？Yes，OK。Alright， 这个思路是对半 ，OK， 对半，right？Yes， 我们要增加 voltage。那我们增加 voltage 会导致什么呢？第一个，它的 terminals 会越变 more positive，right？So more positive， 它就会吸更多嘛。那如果说我增加我还吸的更多的话，代表什么？我还有很多 free 的，还有很多 free electron 在 escaping。那我如果再增加再加这边加2，那加2，我还在增加，加3，还在增加加4，还在增加，所以我们就要一直 increase 到什么呢？当我加10的时候，我的这个这一个 emitter reading 好像是 constant 了那我再加11呢？我觉得 constant 了再加12，又 constant 了，代表什么？我所有的 electron 都被吸到了。OK，right， 所以 that's why 大家看到那个 graph， 为什么会平的，就是这样子。OK。
Here's what we can do. Put the voltage and measure the current. Now increase that voltage. If the current increases, that means more electrons are getting collected. That means we are not there yet. Further increase the voltage. Again, if the current increases, that means still more electrons are being collected. We're not there yet. As you increase the voltage, finally there comes a point where the current will no longer increase. What does that mean? That means no more electrons are being collected. That means we must have hit a saturation. Almost all the emitted electrons must now be getting collected. And so when the current reaches a maximum value and it doesn't increase after that, now we know for sure that all the electrons that are being emitted, almost, we can say, are definitely getting collected. So,
OK， 也就是说，在横线那一边呢，就是 all the electrons emitted equals to all the就是 equals to number of electron collected。OK， 在那个横线那一边。OK。The
moral of the story is, in this experiment, wait for the current to reach maximum. Let me write that over here. The max current, or we can say saturation current, that is equivalent to the number of photoelectrons ejected per second or collected per second, pretty much the same at this point. So the last thing I want you to do, because practically you know how people perform this experiment, they draw graphs. And I know graphs can seem intimidating, but they are really insightful. So what I want you to think about, we now have the whole story, I want you to predict this graph. Let's draw a graph of voltage on the x-axis. So voltage is going to put a battery, voltage of the battery. Versus the current that you detect over here. And the current is often called the photocurrent, because it's the current due to photoelectric effect. So over here we plot the photocurrent. I want you to pause and think about, as you change the voltage, from 0, from when the battery was not there, all the way to increasing the voltage, how would the graph look like? Can you pause? This is the last time I want you to pause. Can you pause and try? Alright?
Right. So 这一个的话 voltage 跟 photocurrent 那其实大家的 graph 已经出来了right？ 所以你 voltage 的话，当你 voltage 是 cos 1的时候，你 photocurrent 是多少？
voltage cos 1的时候
voltage 高上的时候，它有没有 photo current？有没有？啊，但先记得一开始我们没有 battery 的时候，哎，整个东西有没有在走？
有
啊，这个东西有在走啊，alright，所以 battery 有没有这个是过后的事情。但是没有 battery 的时候，我们已经有 photoelectric effect， 整个都已经circuit 已经在走的了 ，right？ 所以当 voltage 高上的时候，你的 photo current 已经是有了的，哎，所以你不能 start from zero 啊，right？ 所以是在中间的。然后当我们的 voltage 一直在增加的时候，我的 current 也在增加，到一个 saturation point，OK？、所以就是一个 curve 上去，然后一个这样子了。
Let's see. So let's start with when the voltage is zero, when we don't have a battery. Do we get zero current? No. Because even without the battery, we saw there will be some electrons ejected in the direction over here. They will get collected and there will be a current. So there might be some current to begin with, even when the voltage is zero. Now, as I increase the voltage, more and more electrons start getting sucked in, and so we would expect the graph to increase, go up. And then eventually we know we hit a maximum, and after that the graph won't increase anymore. So you can kind of guess the graph would go somewhat like this. At this point, at which we reach saturation, that represents our, that represents our photoelectrons, the number of photoelectrons coming out per second. So this means if I repeat the experiment, let's say I change something about my light, I repeat the experiment, and in the new experiment, let's say I get a graph in which the saturation current level is somewhere over here. I now know for sure in this experiment, less electrons are emitted per second. In fact, by measuring this, I can say, okay, half the amount of electrons are being emitted per second. Or if I change something about my light, and now in the new experiment, let's say I plot a graph and I get a graph in which the new saturation current is here, I again know for sure now that more photoelectrons are being emitted per second. So you see, using this clever experiment, we can, just by looking at the maximum value of the photocurrent, we can know how many photoelectrons are coming out per second. The last thing to think about is that if there are air molecules in between, then that will mess up our experiment. So this experiment should ideally be conducted in vacuum, so the electrons are not lost due to by colliding with the air molecules. And that's why this experiment is often conducted in some kind of a transparent chamber, transparent because we want the light to pass through. And so we often choose glass or quartz or some other transparent chamber, and we suck out all the air and create vacuum. And there we go. This is how, pretty clever, right? We can now count how many electrons are coming out per second. And in a future video, we'll see how we can tweak the same experiment and measure with what energies they're coming out. But until then, I want you to think about it, maybe discuss with your friends and teachers of how can you use the same setup, tweak it a little bit, and be able to find what's the maximum energy with which the electrons are coming out.
maximum alright 只是这一边我们要看的是这个right so graph 到这边 maximum 的时候，这一个 point 代表什么？它是这样子，我们 extrapolate 过去，这个 point 代表什么呢？这个是OK saturation OK saturation level， 来把这里是什么呢？这个是 photo current OK。如果讲 current 的话，刚才我们已经讲它是number of photo electron emitted per second 嘛，所以到这一边的时候就是它的 maximum number，right 也就是当它达到 saturation 的时候吧 ，OK，right， 所以这里就是 maximum number of photo electron emitted，OK， 它的 emitted 跟 collected 在这边已经是一样的了 ，OK， 所以 either 你用 emitted 或者是 collected 都是对的 ，right，OK， 好，那接下来第二个 video。OK， 说接下来的 video 啊，这个 tab 的话，OK， 等一下 ，OK，so 关于刚才的 video 有什么问题吗？可以吗？OK， 还可以了哦，不错啊，这个英文非常好 ，OK。所以我也看了他蛮多的 video， 都很好啊，讲的。
那有一个
外国人也是有，蛮多的。来，这 stopping potential. Yeah.
In photoelectric experiments, we are always interested.
Potential. 哇，这还有蛮多 video 的，同学。
你看这里就是你把那个过程一直增加，它那开了在一个这个它的原说就是这个速度原理和它 circuit 平来说就是这个弱的，只要接收到那个原说
OK，
它释放的速度原说。
对，它每一秒释放的，因为我们接收也是每一秒接收的嘛，然后它这个就达到一个平衡，那它就达到了 saturation level。好，好，等下 solar cell 也是要让你们看一看的。solar cell。哇，这样不是选举完你们就考试啊？是吧？你赶快考试，星期一就考。
23，
星期三。3考，考到11月中，11月7号。
2个星期。
哦，2个星期吧。必停课。那一科8。哦 ，OK。Okay, right. So get ready for second video. Second clips. Okay, so 这个 clip 就介绍，为什么我们要去找 stopping potential？ OK， 到底那个玩下来那个 negative 是为什么我们要去找啊？
In photoelectric experiments, we are always interested in finding two things. One is counting the number of electrons coming out per second, something that we discussed in our previous video. And the second, which we'll discuss in this video, is calculating or measuring the maximum kinetic energy of the electrons. So the question is, how do you find what is the maximum energy with which these electrons are coming out? I find it even fascinating that we can even perform experiments to do that. Now, just to quickly recap, we've already seen the experimental setup we used to count the number of electrons emitted per second. The whole idea was the number of electrons collected per second must be a direct indicator of the current. The current directly indicates how many electrons were collected per second. But that did not necessarily be the same as the number emitted per second, because some electrons can be lost. Not all electrons will be collected. And so then we attached a battery to ensure the collector can suck all the electrons. And we realized that as we increase the voltage, this current starts increasing and eventually it maxes out. When the current has reached maximum, that's when I know for sure that all the emitted electrons, almost all the emitted electrons, must be getting collected because the current is not increasing anymore. And that current, we drew a graph of the voltage of the collector versus this current, the current over here. And we found that once the current reaches maximum, that current is a direct indicator, we call that as a saturation current or the max current, is a direct indicator of how many electrons are coming out per second. And we've discussed this in detail in our previous video, so feel free to go back and check that out if you need a refresher. But can we use this setup to somehow figure out with what energies or what kinetic energies are these electrons coming? Or think about measuring how fast these electrons are moving. How do we do that? Well, the trick is you try and stop these electrons. Think about it. If it takes very little effort to stop these electrons, that means the electrons must be moving very slowly. They must be having small kinetic energy. But if it takes a lot of effort to stop these electrons, then they must be having a very high kinetic energy. So the whole idea is you try and stop these electrons. Now the question is, how do we stop these electrons, and how do we figure out how much effort it takes to stop the electrons? I want you to think about it. In this situation, the collector is connected to the positive, so the collector is attracting the electrons. Now, if you want to stop this electron, what should you do? What change can you do in this experiment? You pause the video and think about it. All right. So,
要想想吗？来，Yeah，
frequency of light 少小过 threshold
frequency of light 小过 threshold，then nothing coming out，then
这样好像 stop 那个
yeah，我们要 stop electron stop 这一个这一个 electron from emitting 嘛。但是如果你少过这一个threshold frequency 的话 nothing 嘛，
这是什么的信号？
什么都没有，so 你 detect 到什么都 detect 到。所以呢，什么呢？刚才他已经有一点给了一些暗示了，就是这一个 part 我们能做什么？Yeah, battery, yes, battery, OK。所以这一边呢，就是为什么会发生 negative 那个negative potential difference 啊 ？OK， 因为它 reverse 这个 polarity，OK，、所以你 reverse 这个 polarity 的时候，这一边就变成什么？如果你 reverse polarity 那这边会变成什么？这边变 negative， 然后这边变 positive。OK， 那注意这边的 electron 这边这个 electron emitted 是因为 photoelectric effect， 也就是说这边有 light source 一直照着它 ，right， 然后它这边就产生 electron，right， 所以它 electron 本来是从左到右的，但是如果我现在 reverse 的 polarity， 所以这边变成 negative， 这边变成 positive 的话，那这个 electron 会发生什么事情？它会倒转来，它会 U 盾。
这样
因为它本来它是从这边左边那emit去右手边的嘛，但它跑到一半的时候，跑到一半了过后就它就遇到这边是哪个地方？然后它就 repel， 它就U 盾回来 ，OK， 它就会 U 盾。Alright，OK， 所以我们就会去查看到底它需要多少的 potential difference， 就是说这里到底需要多大的 negative， 它才会导致它完全出不来呢 ？OK， 所以这里我们来看看。
I want my collector to try and stop the electrons, right? That means I need my collector to repel the electrons this time. If I want to make the collector repel the electrons, that means my collector should be connected to the negative terminal of the battery. Ooh, so I have to just flip the battery. That's the modification I need to do. Alright, so let's do that. Let me flip the battery. So I put negative terminal to the collector, put positive over here. So now I'm giving negative voltage to my collector. So now let's think about what's going to happen to our current. Well, when there was no battery, there was some current because there are some photoelectrons were reaching the collector, and as a result, there was a current even without the battery. But now, since I've given a negative voltage to the collector, some of these electrons which were reaching earlier, they will now stop reaching. They'll get repelled and maybe they'll turn back. Maybe this electron will also stop and turn back. But not all. Maybe these electrons have very high energy, so they're slowing down but they don't stop. Slowing down but they don't stop. They still get collected, so you'll still get a current, but the current will now become a little smaller because some electrons are turning back. And since our goal is to find the maximum kinetic energy of the fastest electrons, we should try and stop the fastest electrons. So maybe now I've put, say, 1 volt, negative 1 volt, but let's say I put 1 volt, and 1 volt, the current is still there. So what will I do? I'll say, hey, 1 volt is not enough to stop my electrons. I will increase it. Maybe I'll increase it to 2 volts. And maybe now I find that some more electrons, maybe this electron will also turn back. If this electron will also slow down, stop and turn back. But maybe this electron is still very powerful, slows down, but it doesn't turn back, it's still getting collected. So even at 2 volts, I get a small current, but there is a current. The fastest electrons are not stopped yet. So now, I just increase the voltage. I keep on increasing the voltage, the current keeps on decreasing, but the fastest electrons are still being collected. Eventually, let's say I go to 2.9 volt. Let's say 2.9 volt.
Negative 2.9OK， 它现在意思是 negative 2.9是因为是导反方向了。
Still get a current. That means, let's say this is the fastest electron. It is slowing down, but it's still reaching and some getting a current. So now let's say I increase from 2.9 volt to 3 volt. And at 3 volt, I find my current goes to 0. What does that mean? That means at 3 volt, and I'm taking simple numbers over here so that it's easy for us to understand. At 3 volt, this fastest electron must be coming all the way to here, and must be stopping and turning back. How do I know it stops here? Because I know that 2.9 volt, it was still making it. So at 3 volt, it must have stopped. Now if I increase the voltage further, the current will stay 0. And so I now know that it takes 3 volts to stop my electrons. And this now is an indicator of how energetic the electrons are. Now imagine, if in another photoelectric experiment, it took me 10 volts to stop the electrons. Now I know over there, electrons, the maximum kinetic energy must be much higher. You get that? So this voltage, which we call the stopping voltage, the voltage that is needed to just stop the photoelectric effect, is a direct indicator. So let me write that. The kinetic energy maximum can be directly found out by finding, can be measured by finding the stopping voltage. Stopping voltage is the minimum voltage needed to stop the photoelectric effect.
Right， 所以maximum kinetic energy 我们可以用 stopping voltage，OK， 也就是说大家看到那个图，那个 Vs 拿来穿什么，就是可以直接去计算这个 kinetic energy maximum，right？So stopping voltage 就是大家的 Vs 大家看到在那个图里面的 Vs，right？So stopping voltage is the minimum voltage needed to stop the photoelectric effect，OK？所以这边我们并不去alter 那个 light source 的 frequency，OK， 反而就是用这个 setup，OK， 用 experimental 来去 control 这个 photoelectric effect，OK， right now。
And get this, not only is there a direct correlation between them, if you know the stopping voltage, you can actually find out what is the maximum kinetic energy of these electrons. Yeah, and we'll do that in a second. But before we do that, I want you to complete this graph. Okay? So now we are on this side of the graph because we are putting a negative voltage to our collector. So I want you to think about what would the graph look like as I increase the voltage in the negative side. So can you pause and try and complete that graph? All right. So we know as I increase the voltage in the opposite direction, giving negative voltage, the current becomes smaller and smaller and eventually goes to 0. So I know the graph should somehow go to 0. Right? So it turns out the graph goes to 0 somewhat like this. And this point at which the current just stops, the minimum voltage needed to stop the current, that is our stopping voltage. In our example, we took that as 3 volts. Alright, now let's come to the last part. Given the stopping potential, can we actually tell how much kinetic energy this fastest electron had? The answer is yes. But how? Well, one way is to use equations and do it, and I find that dull and boring. Another way is to do it logically. I first ask myself this question. What does it mean when I say the potential difference here is 3 volts? What is the meaning of that statement? Potential difference is an indicator of how much energy a charge is gaining or losing when it moves from one point to another. So when I say 3 volt, it means a charge, when it goes through that 3 volts, gains or loses 3 joules of energy per coulomb. That's the meaning of this. That's the meaning of potential difference.
所讲到这一个什么 formula？ 什么 formula？ voltage 的。Yes. Okay. All right. So V 等于 E per Q. All right. E per Q. Right. Energy per coulomb. Q 就是那 charge. All right. 第四课我也忘了，第三了是吧？第三了，第三前面有2个 formula 啊。All right. So 一个是还有一个是。我也忘了，大家再自己看啊。
This fastest electron has lost 3 joules of energy per coulomb. But since the final energy is 0, that means it must have had 3 joules of coulomb to begin with. And so that means the kinetic energy of the electron, this is the fastest electron, must have been 3 joules per coulomb to begin with. You might say, what is the meaning of that? 3 joules per coulomb to begin. What is the meaning of that? Well, this means that if electron had 1 coulomb of charge, then its kinetic energy would have been 3 joules. If electron had 2 coulombs of charge, then its kinetic energy would be 3 joules times 2. If the electron had 10 coulombs of charge, then the kinetic energy would have been 3 times 10. But we know how much charge an electron has. An electron has 1.6 times 10 to the power minus 19 coulombs of charge, and therefore its kinetic energy must be 3 times this number, and there we go. We have now measured the kinetic energy of the fastest electron that was there in this experiment. And of course, you can calculate that. Put cancels. 16 3s are 48. So this would be 4.8 times 10 to the power minus 19 joules. Isn't this mind blowing? That we can perform an experiment and find out the kinetic energies of electrons. Oh my God! I can't believe this, that we can do experiments like these. But anyways, remember, we can only do that for the fastest electron, because if you take some other electrons, I can't do that because these electrons did not travel the entire 3 volt. So this electron must have traveled only for 2 volts before turning back. This electron must have been stopped maybe just by 1 volt. And therefore, this is the energy of only the fastest electron. So this is the maximum kinetic energy. Okay. Now, last thing is, because these energies are so tiny, instead of writing it in joules, we can write it another way, the another unit. And the way to think about this is, we'll write 3, and instead of substituting the value of E, we'll just call that as E. We'll just keep it as E. So we'll keep this as E, and so what remains is just joules per coulomb, which is volt, 3 electron volt. And so we can just say, hey, the maximum kinetic energy in this experiment is 3 electron volt. And what you see is that's the same as the stopping voltage. So if the stopping voltage was 10 volt, I immediately know the maximum kinetic energy in that experiment must have been 10 electron volt. And if you want to convert it to joules, just substitute for E, multiply, and you'll get it in joules. Incredible, isn't it? So long story short, if you want to calculate the stopping maximum kinetic energy, you basically find out what's the stopping voltage. The stopping voltage itself equals the maximum kinetic energy, but in electron volts. If you want in joules, then you just multiply that number with 1.6 10 to the power minus 19, and you'll get that. So putting it all together, if you want to count how many electrons are emitted per second, then that is indicated by the saturation current. And if you want to count what is the maximum kinetic energy with which these electrons are coming out,
这里做一下笔记啊。如果你是要算这个 number of electron emitted per second，就是看这个 saturation current，OK，就是看这个 graph 的那个 y-axis 啊。OK， 如果是你要算 number of electron emitted 啊，就是看这个 y-axis。Right， 那如果你是要算这个maximum kinetic energy， 就直接看它的 stopping voltage。
many electrons are emitted per second, then that is indicated by the saturation current. And if you want to count what is the maximum kinetic energy with which these electrons are coming out, that is indicated by the stopping voltage. And now we can play with this. We can change the intensity of light, change the frequency of light, and based on what happens to the saturation current, and based on what happens to the stopping voltage, we can now tell what's happening to the number of electrons coming out per second, and what's happening to the maximum kinetic energy of these electrons. In this video, we're going to change.
Okay, right. So 这个就是完整的故事 OK，so 我们只看到一个 graph 了 ，right， 然后它后面的故事非常非常多 ，right， 大家看了应该会比较理解了啊。OK， 那当然这个 link 我会 send 给你们，我会 send 去 group， 说大家在 revise 的时候再拿出来看。OK， 好 ，so OK 吗？大家？boleh？ boleh 啊 ，boleh faham 吗 ？Okay, so right, so. Okay. Okay. Right. 然后再回到这一个，哎 什么事情？啊？有吗？课本有吗？有这个没有啊，做到一个少，那他们一共几次？就没有，就这样，就这样，right？Okay, so even reference books 啊，它只是给 graph 的啊，就它只是带过而已。OK，then alright，好，那我们来看这一个 last part，alright 就是 application 啊。OK，好。So application 的话，这个 photoelectric effect 那 mainly 啊，就是跟光有关系的东西啦。Right, so solar cell, remote control, traffic light control 跟 automatic door opener。OK， so 这些是light sensor。OK， 主要是 light sensor 啊。OK， so 这个4个东西啦，它的 application， 大家就记得这4个就好了。OK， 好，那接下来这一个啊。目前是没有问到这样子深啊，但是不懂它会不会突然间爆出来啊 ？Okay, right. So photo cell and solar cells are devices that convert solar energy into electricity. It's made up of semiconductor materials. Okay, so 每一个 solar cell 呢，我们看它黑黑的部分啊 ，right？ 那其实是 silicon，right？ 都是用 silicon 做的 semiconductor 嘛。我们知道 semiconductor 是 silicon，mainly silicon，right？ 那它的第一排啊。OK， so 它是 silicon。OK，so 这个 OK， 我们先读完先啊。Right， it's made out of semiconductor materials。然后呢，所有的 solar cells 呢，它总共其实有3层啊。Right，so 这边你会看到有 N-type silicon、P-type silicon。那 N-type 跟 P-type 我们在chapter 几 ？chapter 5。哪一个 chapter 啊 ？Right，so 那个 chapter 我们有解释到 N-type N-type 跟 P-type。OK，so N-type 跟 P-type 那时候我们是讲 diode 吧，diode。Alright，so N-type 呢这边是 silicon， 然后还再加上 phosphorus。phosphorus 是 K 啊，对吧 ？K potassium 啊。它 phosphorus 是哪一个？这个是 phosphorus 啊，but 这种是不是 K plus？ potassium 啊 ，K 是 potassium 啊，那个 phosphorus 是当然有那个 chemical periodic table phosphorus 什么？忘记了 K 什么鬼啊？Fl 是 fluorine，F 是 fluorine，P 是 potassium，P phosphorus 是 P，OK，alright，OK，so silicon plus phosphorus，OK，so 它这一边它就会变成negative type 的 silicon 了 ，OK， 因为 phosphorus 本身是它的 electrons 多过它的 host。OK， 所以它就变成 N-type。那 P-type 呢是 silicon 加上 boron。OK，so boron 它只是小部分而已。OK，so silicon plus boron 啊。OK， 如果它有问到这样东西。OK， 那这个其实是 solar cell 它怎样去运作的原理啦。OK，solar cell 运作原理。So 你们有兴趣想要知道吗？这个。这个 solar cell 怎么会照一下太阳就有电呢？那考试会不会问就我觉得很大可能是不会问的啊，只是看大家要不要去知道而已。当额外知识啊。OK， 好那我们先看看这个第4种，right？So 为什么我们用 semiconductors？OK，so 为什么不要用铁直接当成 solar cell 呢？Right, so semiconductor is that low frequency, visible light 呢都已经足够了 ，alright, to produce photoelectric current. OK，所以这是为什么我们用 semiconductor， 来是个 solar cell 了，so low frequency 就够。OK， alright， 那给大家看一看啊，到底 solar cell 是怎样做的 ？OK，right，so N-type P-type， 同样的也是要看一看 video， 也是要看 video 非常多的 video。这个 video 非常非常的好啊。我会看到不该看的东西。
然后我的宝宝巴士，
宝宝巴士。Stopping，alright， 或者对，那好手消的看到的是是。这两个都要看一看，先看清楚。OK， 好，好。按照了 ，OK。
Renewable energy source is solar energy. But how is solar energy used to generate electricity? A photovoltaic or PV system is used to convert the solar or light energy into electrical energy. The basic component of the PV system is known as the solar cell. A single solar cell has the capacity of producing about 0.5 volts of electricity. A solar panel or solar module is the combination of several solar cells connected in series to generate usable voltage. The solar panel voltage can be increased by increasing the number of solar cells. For example, 30 solar cells connected in series will produce an output of 15 volts. A combination of solar panels connected together is known as solar array and can be used to achieve required current and voltage.
OK， 因为每一个 solar cell， 因为我们看到 solar cell 它都是一格嘛，所以因为一格呢大概只是0.5 volt 的，它能 generate 0.5 volt 而已，所以就是要很多了。OK， 就好像 Tesla 的车为什么这样子啊？就是把 battery 一粒不够，我们2粒，2粒不够4粒就是这样子而已。
Voltage. How does the solar cell work? The generation of electricity on exposure to sunlight is known as the photovoltaic effect. This principle is used by solar cells to produce electricity. The solar cells are made up of semiconductors, mainly silicon, and comprises 3 layers. The top layer, called the N-type layer, is comparatively thin and contains high concentration of electrons. The bottom layer, called the P-type layer, contains high concentration of holes. When the P-type and the N-type semiconductor is joined, it forms a PN junction. On form
可以说 PN junction 就是大家在等要看到的东西这个关系，好嘛
forming a PN junction, the electrons of the N-type material try to reach the P region.
PN junction 我们也叫做什么 junction 呢？
那叫不然，
PN junction 我们叫什么？
是有一个什么雷尔，
什么 layer？ 8 layer。什么 layer？
搬了。
PN junction。 什么 layer? Yes, depletion layer. Okay, depletion layer. Alright, so depletion layer 为什么我们叫 depletion？ 为什么我们叫 depletion layer？ 那个 gap，OK， 里面呢是完全是没有 charges 的 ，alright， 所以我们叫做 depletion layer。那来看一看。
creating a negatively charged layer. Similarly, the holes of the p-type
比如
material
说，因为它下面是 p type positive 嘛，上面是 n type negative 嘛，right？ 所以上面的 electrons 就会因为 p type 我们讲的是 holes 比较多，上面是 electrons 比较多 ，right？ 所以 electron 它会吸引去填满那些 holes 啊，所以它形成一个 barrier 这样子。那
try to reach the end region, creating a positively charged layer. This region between the two layers is known as the depletion region of the semiconductor. Sunlight penetrates the top thin layer easily to reach the depletion region. Due to the deficiency of charge in the depletion region, it contains neutral atoms. These neutral atoms are broken when the photons from the sunlight strike the depletion layer. This knocks the electrons from the neutral atoms, leaving behind the holes and producing free charge carriers.
OK， 所以中间 depletion region 呢，它没有 charge，OK， 但是它有 neutral，alright， 所以当那个light source 照到它的时候，它会把这一些 neutral atoms 把它分成就是 positive 跟 negative charge 的ions 啊。
Then the electrons move towards the n-type layer and the holes move towards the p-type layer due to the electric field present in the depletion region. On connecting an electronic circuit, the electrons flow through it, generating electricity to electrical devices like bulb, fan, etc.
OK，
Please subscribe our channel and join.
这个它讲的是一个大概啊 ，OK， 所以如果你要看更仔细的呢是这个 ，OK， 说因为这个是大概这个 yes， 这个也是。
The electrons will recombine. Voltaic cell produce electricity. Energy from the sun is the most abundant and absolutely freely available energy on planet Earth. In order to utilize this energy, we need help from the second most abundant element on Earth, sand. The sand has to be converted to 99.999% pure silicon crystals to use in solar cells. To achieve this, the sand has to go through a complex purification process as shown. The raw silicon gets converted into a gaseous silicon compound form. This is then mixed with hydrogen to get highly purified polycrystalline silicon. These silicon ingots are reshaped and converted into very thin slices called silicon wafers. The silicon wafer is the heart of a photovoltaic cell. When we analyze the structure of the silicon atoms, you can see they are bonded together. When you are bonded with someone, you lose your freedom. Similarly, the electrons in the silicon structure also have no freedom of movement. To make the study easier, let's consider a 2D structure of the silicon crystals. Assume that phosphorus atoms with 5 valence electrons are injected into it. Here, one electron is free to move. In this structure, when the electrons get sufficient energy, they will move freely. Let's try to make a highly simplified solar cell only using this type of material. When light strikes them, the electrons will gain photon energy and will be free to move. However, this movement of the electrons is random. It does not result in any current through the load. To make the electron flow unidirectional, a driving force is needed.
OK， so 这个 light source 呢，它会把这个 electron emit 出来，但是呢，它们有一个方向 ，OK， 所以他们需要一个 force 呢去引导他们flow 去 one direction 这样子 ，right？ 所以现在怎样去 create 这个 driving force 呢？
An easy and practical way to produce the driving force is a PN junction. Let's see how a p-n junction produces the driving force. Similar to n-type doping, if you inject boron with 3 valence electrons into pure silicon, there will be 1 hole for each atom. This is called p-type doping. If these two kinds of doped materials join together, some electrons from the n side will migrate to the p region and fill the holes available there. This way, a depletion region is formed, where there are no free electrons and holes. Due to the electron migration, the n side boundary becomes slightly positively charged, and the p side becomes negatively charged. An electric field will definitely be formed between these charges. This electric field produces the necessary driving force. Let's see it in detail. When the light strikes the p-n junction, something very interesting happens. Light strikes the n region of the PV cell, and it penetrates and reaches up to the depletion region. This photon energy is sufficient to generate electron hole pairs.
OK， 所、这个 electron hole pairs 来自哪里啊？这个 electron hole 这个 electron hole pairs 来自哪里？从哪来的 ？neutral atom。OK，neutral atom， 刚才第一个 video 的 ，alright。
Depletion region. The electric field in the depletion region.
OK， 所、以刚才我们有看到它是 positive 在上面 ，negative 在下面，为什么？ OK，right， 所以你要 combine 跟第一个 video 哦 ，OK， 所以刚才第一个 video 什么呢？我们的 negative 那个 electrons fill out 这边的 holes 嘛 ，OK， 所以它就形成了一排在这边，就是 electron 形成一排在这边，然后你的 holes 这边 positive 的跑在这边，就是 positive 在这边 ，right，that's why positive 在上面 negative 在这边 ，OK， 因为上面是 n type， 那你会有一个疑问嘛？那是不是上面是 negative 的 negative charge 的这一个 plate 为什么是 positive charge？OK， 就是因为这边的 holes 跑上去能够形成一条 positive charge， OK， 并不是全部 positive， 是这一条 ，OK。
N region of the electric field in the depletion region drives the electrons and holes out of the depletion region. Here we observe that the concentration of electrons in the N region and holes in the P region becomes so high that a potential difference will develop between them. As soon as we connect any load between these regions, electrons will start flowing through the load. The electrons will recombine with the holes in the P region after completing their path. In this way, a solar cell continuously gives direct current.
OK， 所以这边讲到一个东西啊 ，solar cells give direct current。OK， 它只有 direct。
In a practical solar cell, you can see that the top N layer is very thin and heavily doped, whereas the P layer is thick and lightly doped.
OK， 所以这个是 practically used 的。OK， 所以刚才大家看到是平均 balance 的嘛。OK， 这里我们的 N type 是很薄的 ，OK， 然后 P type 是很厚的。那为什么要这样子呢
？This is to increase the performance of the cell.
Increase the
Just observe
performance.
the depletion region formation here. You should note that the thickness of the depletion region is much higher here compared to the previous case. This means that, due to the light striking, the electron hole pairs are generated in a wider area compared to the previous case. This results in more current generation by the PV cell. The other advantage is that due to the thin top layer, more light energy can reach the depletion region. Now, let's analyze the structure of a solar panel. You can see the solar panel has different layers. One of them is a layer of cells. You will be amazed to see how these PV cells are interconnected. After passing through the fingers, the electrons get collected in bus bars. The top negative side of this cell is connected to the back side of the next cell through copper strips.
不用看了，这些，这些不考试。OK， 所以我们只要了解那个 PN junction， 到底里面发生了什么事情。OK， 就是这样子。Right， 好，那可以吗？大致上可以理解 solar cell 怎样去运作啊。可以说大家有可能进 engineering 的时候可以去做一做。OK， 那东西。OK， 好嘞，就是这样子啦，就这样子啦。OK。 ，right， 好，那我们去做一做这个 checkpoint 的练习。checkpoint 7.3，尝试做一做。这里会太暗吗？要开灯吗？对啊。OK， 所以大家做一做啊。OK， boleh。brighter light。OK。OK， 好，来我们来看一看了。OK， 第一个 will brighter light。OK， brighter light 这边指的是什么意思 ？Intensity。All right， 所以 emits more electrons from than the dimmer of the same frequency。Yes or no？Yes。All right， 所以这个讲的是 number of electrons 罢了啊。All right， 所以 yes 啊。OK，so yes， 那我们就要写一写了。OK，so 这边就是 the number of photoelectrons emitted， 或者 number of emitted photoelectrons depends on intensity of light。Right， 所以我们写一个解释给他啊。Okay. You know, depends on intensity of light. Okay. Then B. Will high frequency light emits more electrons than a low frequency light? High frequency 跟 low frequency? No. Alright, no. Right, so no 的话那个 number of emitted electrons 那个上面我们已经写了嘛。Right， 那这边的话 frequency 会影响什么？ Kinetic energy. Alright, so frequency of light will only affect kinetic energy of electrons. Kinetic energy of photoelectrons. Right? The frequency of light will only affect the kinetic energy of photoelectrons. Okay, 好，我这 OK， 对吧？有哪个字看不懂？对啊，随便的。Only affect kinetic energy of photoelectrons. OK， 不对啊。Right， 不对 ，AB 可以吗？可以啊。OK， 来 Q2。Right, so state three properties of photons. OK, Einstein photoelectric equation 啊，这里有可能没有写到这个。Right, right, so 三个 properties 的话，其实，它跟 assumption 是一样的东西啦。OK, so 第一个是，呀，这个要写美一点啊。
有重量上，
什么？
我当时有重量上。
没有重量的 ，yes，OK，but 没有重量，但是我们要它其实在里面计算的是它是 either quanta，OK， 它是 quanta 的，或者它是 discrete 的一粒一粒的啊，它才可以这样计算 ，right？ 所以第一个是 photons are either quanta，right？ 这是 Max Planck 讲的 quanta 了啊 ，quanta or discrete energy carriers. Okay, right? Photons are either quanta or discrete energy carriers. Alright, so 这个是 first, OK， 这个是第一个条件 ，OK， 第一个characteristics。Right， 那第二个呢？photon energy is proportional to frequency. Photon energy is proportional to frequency. OK， 就是 frequency 越高，那我的 energy 就越高 ，right？ So energy 这边，就是跟electrons 的 kinetic energy， 不对 ，alright？ So 这个是 light source 的 frequency。OK，light source 的 frequency 会影响到 photon 的 energy，right？ 并不是 electron 的 energy 啊。Right， 那第三个是什么呢？就是photons transfer all energy。photons transfer all energy to the electrons they interact with. OK， 所以这个是它三个 characteristics 啊。OK， 因为我们在算啊，因为 equation 是很 ideal case 的。OK， 它是100%，right？ 所以它没有说90% efficiency，no，right？ 所以它这个第三个是非常重要，就是 photons 它会 transfer 所有的 energy 去 electrons。OK， 所以才能这样计算呢，你才能用 HF 来去计算 ，right？ 没有的话没有办法啊。OK。Right, so 这个三个可以说是right, three properties of photon 啊 ，OK, in Einstein photoelectric equation 啊 ，OK, Einstein photoelectric equation 就是那个东西啦，就是 Ke max, OK, Ke max equals to E minus work function, right? 这就是 Einstein 的photoelectric equation, right? Okay. Then B, use this Einstein's equation to plot a graph of maximum kinetic energy against the frequency of incident light. Okay. Right, so we need to plot. All right, so right, when the frequency, when the kinetic energy. Right, so 这个应该大家比较熟悉了啊。Alright, so frequency，因为我们需要一个 threshold frequency，right， 所以你不能从零开始哦。Right, so 这里是 threshold frequency。Right， boleh lah。OK， so 这个就是那个 graph 了啊。OK， threshold frequency。好，那接下来Q3， what is the energy in joule and electron volt of a purple light photon that have a wavelength 420？啊，所以这个就是use your formula 了啊。So energy， 还记得吗？formula？ Okay, E 等于 HF, right? Then, yes, okay, so C per lambda. Right, so F 换成 C per lambda， 因为 C 等于 F lambda。Planck constant 啊，6.63啊，忘记了。为什么6了？阿波高多啊，6.02啊。63，3乘18。Then we got the wavelength. Okay, berapa? 啊？
也是70。
OK， 7.66 OK， 7.4就还是4.74就可以了。OK， 然后乘10，8减19。Alright， so 这个 joule，then 我们需要 electron volt 还是要 electron volt？ So 1.6除要讲换气 electron volt 啊。Yes。2.96啊，就2.96 eV，OK。Right， 所以这个是需要除的啊。Right， so 1 joule 等于，不是倒反了，1 eV 等于1.6乘。1 eV 等于什么？1.602啊，乘10减19就，Alright，OK， 所以你从 joule 换去 eV 你要除，OK 你要除啊，不是乘啊。Right， 好，那这边大家也可以看到了啊，如果是 eV 的话，大多数是不会有什么 power 的 ，OK， 就是小小的一个数字这样子。OK，but joule 的话 we got powers。OK， 好，那接下来B， what is the maximum kinetic energy of an electron emitted from calcium purple light given that the electron volt function 2.71 0.25 eV purple light 然后 volt function OK，right so 就是用 formula 而已啦啊 OK，so Ke max equals to E minus work function. Alright, electron given that. Okay. So 2.96减掉 work function 减掉2.7， so 0.25 EV。Okay. Everybody know? Right, then Q4. The metal surface has a work function and method with a light ray determine the maximum wavelength. Maximum wavelength that causes the photoelectric emission. The function. Macam mana? Maximum wavelength. 这次我们只算 threshold frequency。那我们之前有做过maximum wavelength。OK， 那其实我们会发生这个 photoelectric effect 呢，我们一直在增加我们的 frequency 嘛。OK， 直到我们过了 threshold， 我们才会产生这个 photoelectric effect。那问题是，当我们在增加 frequency 的时候，它的 wavelength 会发生什么事情？它会 decrease。OK， 因为 frequency 跟 wavelength 本身是 inversely proportional 的嘛。OK， 所以当我们到 threshold 的时候 ，threshold frequency 的时候，就是我们的 minimum frequency， 也代表我们的 wavelength 是 maximum。Alright，OK， 所以我们要算 maximum wavelength， 你就要往 threshold frequency 去想。OK， 所以你要先算你的 threshold frequency。来，可以吗？来，给我一个 number， 来吧。可以把它换成nanometer。Yes。你就换过几个点罢了嘛。什么数字？你要查什么数字？前面是什么数字 ？wavelength 嘛，现在我要 wavelength 嘛，所以 wavelength 是吧？那个 nano 是10.9嘛。OK 那前面的数字你们拿多少？什么 number？ 前面你们算到多少？多少？7.24， no。Yes， 拿不到。OK， yes， 也就是414 nanometer， 算得到吗？414 ，OK 这不用了，因为它很小Right， 所以一开始你要从 work function 看Right，so work function 就是等于 HFO。Right， 就是这个 threshold frequency。Right，so 当然你可以不用去算 threshold frequency 出来先 ，OK， 我们可以直接把它换成这个 C per lambda max。OK， 因为 F 等于 C per lambda 嘛 ，Right， 也就是我们的 lambda max。Right， 但 work function 当然这一边它是 EV。OK，means 你必须把它换成 Joule 了Right， 所以我把它换下来的话 ，lambda max 就 equals to HC over 3.0 EV。 OK， 所以我就去算这个就好了。Right, so 6.63乘10 negative 34 then 3乘18 then over 3 then times 1.6 times 10 to the power of negative 19, you will get your answer now. Okay. Right, this is it. Okay, then B, the maximum kinetic energy. So the maximum kinetic energy, so Ke max equals to E minus work function. Alright, okay, so E 算多少 ？Okay, so 它给 wavelength 哦 ，alright, so 它没有给 frequency. Okay, so E 就等于 HF 就对了 ，alright, E 就等于 HF。OK， 当然了，这个是一粒 photon 啊，alright， so 这个是一粒 photon， 所以 E 等于 HF。Right， 那说如果他讲他有number of photon，OK， 你就要 add HF 啊。
我觉得8乘10到
final answer 吗？E 5.683。其实你可以OK，Alright，OK，OK。他讲 energy，then 减掉 work function，so work function 是3.0嘛，so 3.0乘1.6乘10减19，可以说这个是 work function， energy。OK，so K max 算多少？883乘10，我差减20，这个 in joule 了啊。OK，so either 你把它换成 EV，OK 也可以，或者是 joule 也可以啊。That depends on the questions 啊。OK。
我的指网。
Right, so speed of the photoelectrons. Okay, so speed 的话就是从我们的 kinetic energy 去算了啊。So kinetic energy 就是1/mv square。so 这边我们需要 mass of electrons 啊。Right, so mass of electrons 是9.11乘10 negative 31 kilogram。这是 mass of electron。Right, so velocity 算到多少
4.45乘10
？OK。Right，这样子咯。 给回家当答案，从1点到10点都在念经的。嗯，惨。OK，right， boleh吗？OK，so 这个 topic 就 habis 了啊。OK，so 希望大家听得明白啊，这个 topic 啊。OK， 好，那我给你们很多练习嘛哦，谁了？够时间去讨论嘛？这个不用讨论嘛？用啊，翻色给你们。因为要给你们看一看这个 SBM question， 你们学校有给你们做了吗？啊？做了 SBM 啊？活该，我再做一次。那我在想，我学校会不会给你的是？有吗？有。一模一样，一模一样。这个谁要帮机场？第二呢？后面。可以说这个是 SBM question 上啊。那right， before 我们考试我们要见几次啊？2次、3次。
不是有一个神奇就找到一个脑子里面，有一次。那你们做几份啊？就是 SBM 题目啊。没有在写，是啊。用啊，他会不会用这本书啊？真的是用这本书啊？让我拿另外一本吧。拿另外一本。你们考试那个礼拜，你们要自己复习还是怎？还没for 5 月。啊，那个礼拜你们还要补吗？你们是第一个礼拜考 physics 还是第二个礼拜？第二个礼拜。2个礼拜半呢。第一个。OK。 还有个白日场的。
多股能回家。
像下个礼拜，你们学校有到4点多，这礼拜，星期日。啊，不好啊，不可以的。chemistry 到4点多，你们都有吧？都有去。4点多。
3点。
2点要3半。早上你们也是有补习吗？想修吗？
应该是8点到3半。
2、3半的。也就一样时间吧。下个礼拜一样时间，还是你们
5点到7点
？5点到7点，还是你们要早一点？还是中间1个小时半，你们只要等到睡觉就行。看你们了。下礼拜呢，你们要4点还是4点半？啊？你们要吃东西还是什么吗？ 你们是在2点之前是你们补习到几点？啊，1点半补完，然后还又借，哇，可以吗？对，可以吧？够吗？你们全部都有上，全部都有。OK，so 就是挨到4点还是4点半？4点半了。OK，给你们1个小时时间，4点半。所以下个星期日4点半到6点半 ，OK 吗？对啊。OK，so 星期六我们再 remind 多一次了。OK，right，so 那一个练习的话，那我们应该是不够时间讨论了，我就把答案发给你们吧，你们自己做啊。因为有什么问题我们可以讨论的。then 做，OK， 做 SPM 题目，我们讨论 SPM 题目 ，right？ 那当然我们只是 grab 几个有问题的题目啊，所以大家一定要做啊 ，OK？ 我们没有媒体去讨论的。OK，right，so 今天就到这一点先，谢谢大家。Yes，
你不要想跟我谁有关，但是我只要开发他只要几个那个 UTF 嘛，只要他们小同事可以，对，交泰，是他是可以，你可以看啊，我可以看，可以看，你看什么？你可以看，你可以。你可以怎么讲？没有，是film， 是吧 ？electromagnetic field， 你可以讲的。你可以讲，是吗？这什么？你找过？这2个都一样哦。这他这边都讲啊。different of 左边的比例，对吧？430啊。最主要点就是那个哇，没有他提过different of 不是点，是这边他写430，460。啊，怎样啊？讲叫什么理解的本位呢？或者是他抄下来讲他蛮贵的。你看，是。啊，对，我有这个题目了。OK， 你做到那里了，这个。